What if I told you that beneath the icy crusts of some moons in our solar system lies a hidden world, teeming with the potential for life? Just beyond our own planet, in the depths of the cosmos, we find celestial bodies that beckon us with the promise of scientific discovery. Welcome to the fascinating realm of astrobiology, where we explore the icy moons of our solar system, focusing particularly on Europa, one of Jupiter's many satellites, along with others like Enceladus and Ganymede. Imagine a moon, its surface glistening with ice, but beneath that frozen exterior, there exists a vast ocean, perhaps even more voluminous than our own. This is Europa, a moon that has captivated scientists and dreamers alike. Discovered by Galileo Galilei in 1610, Europa presents an intriguing enigma. Covered in a thick layer of ice, this moon orbits Jupiter, one of the largest planets in our solar system, creating a unique set of conditions that could be remarkably conducive to life as we know it. But what makes Europa so special? To understand this, we must first delve into its structure. Europa is believed to have a surface composed primarily of water ice, with a subsurface ocean lying beneath it, potentially reaching depths of 100 kilometers. This ocean is kept warm by the gravitational tug-of-war between Europa and Jupiter, a phenomenon known as tidal heating. This process generates enough heat to keep the water in a liquid state, creating a stable environment where life could potentially thrive. As we ponder the possibility of life in these extreme conditions, we must ask ourselves, what kind of organisms could survive in such an environment? Astrobiologists often turn to extremophiles for insight. These are organisms that thrive in extreme conditions on Earth, such as the deep-sea hydrothermal vents or the acidic lakes of Antarctica. If life can exist in these harsh environments here on Earth, why not in the subsurface oceans of Europa? The potential for hydrothermal vents on Europa's ocean floor adds another layer of intrigue. On Earth, these vents are rich ecosystems, home to a variety of life forms that depend on chemosynthesis rather than photosynthesis. If similar vents exist on Europa, they could provide the necessary nutrients and energy sources for life to flourish. This leads us to an exciting question. Could we find life that thrives in complete darkness, relying solely on chemical reactions for sustenance? The search for life on Europa doesn't just stop at theoretical discussions. In recent years, missions have been proposed to explore this icy moon more closely. NASA's upcoming Europa Clipper mission aims to conduct detailed reconnaissance of Europa's ice shell and subsurface ocean. Armed with a suite of scientific instruments, Clipper will analyze the moon's surface composition, study its ice thickness, and even search for signs of plumes erupting from the surface, which could provide direct samples of the ocean beneath. But Europa is not the only icy moon capturing the attention of astrobiologists. Enceladus, a moon of Saturn, is another candidate in the hunt for extraterrestrial life. Similar to Europa, Enceladus is covered in a thick layer of ice, but what sets it apart is the presence of geysers that erupt from its southern pole. Discovered by the Cassini spacecraft, these plumes are rich in water vapor, organic molecules, and other compounds. The findings from Enceladus suggest that its subsurface ocean could also harbor the ingredients necessary for life. The similarities between Europa and Enceladus are striking, but they also pose questions about the diversity of life that might exist on these icy moons. If life were to be found on both, would it share a common ancestry, or would it have evolved independently, adapting to its unique environment? This notion of convergent evolution could open up our understanding of how life might develop in different contexts throughout the universe. As we explore further, we cannot overlook Ganymede, the largest moon of Jupiter and the only moon known to have its own magnetic field. Ganymede's surface is a mix of two types of terrain: bright regions with ridges and grooves, and darker areas littered with impact craters. Below its icy crust, scientists suspect there is a subsurface ocean, similar to Europa and Enceladus. The potential for life on Ganymede raises the stakes even higher in our quest for extraterrestrial biology. Each of these moons showcases the complexity and resilience of life, pushing the boundaries of what we understand about habitable environments. The icy worlds of our solar system serve as a testing ground for astrobiological theories, challenging our assumptions about where life can thrive. As we peer into the distant future, the implications of discovering life on these moons would be profound. It would not only answer the age-old question of whether we are alone in the universe, but it would also reshape our understanding of biology, evolution, and the potential for life beyond Earth. Moreover, the exploration of icy moons is not just about finding life. It's also about understanding the origins of our own planet. The study of these celestial bodies could provide clues to how life began on Earth, offering a glimpse into the processes that may have given rise to life in the first place. Imagine the thrill of uncovering a microscopic organism beneath the ice of Europa or Enceladus. Such a discovery would propel humanity into a new era of scientific inquiry, sparking debates about ethics, life's definition, and our place in the cosmos. But as we set our sights on these distant worlds, we must also consider the challenges that lie ahead. The harsh environments of icy moons present significant obstacles to exploration. The thick layers of ice must be penetrated to access the liquid oceans below, and the vast distances between Earth and these moons mean that missions will require advanced technology and significant time commitments. Yet the allure of discovery drives us forward. Scientists and engineers are developing innovative approaches to study these moons, from landers that could drill through the ice to autonomous underwater vehicles capable of navigating the dark ocean depths. The ambition to unravel the mysteries of these icy worlds is a testament to human curiosity and resilience. As we conclude our exploration of the astrobiology of icy moons, we are left with a sense of wonder and anticipation. The prospect of life beyond Earth has never been more tangible, and with missions like Europa Clipper and further investigations into Enceladus and Ganymede, we are on the brink of potentially groundbreaking discoveries. So, what happens next in our quest to uncover the mysteries of space? Will we find evidence of life in the dark, icy oceans of these moons? The answers may be closer than we think, and the journey is just beginning. In the grand tapestry of the universe, the icy moons of our solar system represent an extraordinary chapter filled with questions yet to be answered. Each mission, each discovery, brings us one step closer to understanding our place in the cosmos and the possibilities that lie beyond our blue planet. As we contemplate these possibilities, we invite you to join us on this journey of exploration and wonder. The quest for knowledge is a shared adventure, and together, we can uncover the secrets of the universe, one icy moon at a time. Keep watching to discover more about the wonders that await us in the vast expanse of space. Don't miss out, subscribe now.